Very good morning, students. So in this video I would like to discuss the Newton's advancing difference method. So in a shortcut way I have written just a Newton's method for understanding sake. Okay, so in this Newton's advancing difference method, what are the how we can compare from binomial to Newton's? First we need to observe that. In the binomial expansion method, what did you observe there? First thing is there must be a common difference among x independent values. Clear? So common difference must be there. Even in the Newton's method also same condition follows. Common difference must be there. Remember. And second important point, the missing in the binomial expansion, the missing value of y must be one of the value of x. The missing value of dependent variable y must be one of the value of independent variable x. Clear? But in Newton's method it is not mandatory. See, easily you can identify the question. Interpolate the number of persons living in the age of 25 years. It is mentioned. So they are asking us to interpolate number of persons who are living at age 25. So ages are given 20, 30, 40, 50. See there guys, what you have to calculate? 25. 25 comes in between 20 and 30 or no? Right? So and then number of persons we have to interpolate. As you all know that interpolate means estimating within the range among dependent variables y of independent variable x not to xn. So in between we have to estimate it. Now this Newton's method, generally clearly it will not be shown that the missing value in the question or tabular form. Just observe the tabular form. Number of persons, did they just miss any observation there? No. Like binomial in Newton's method, the clearly missing value will not be shown. Remember. So always in between it has to be Newton's method. So 25 years, that also comes in between, and even the number of persons observation also will be in between only. Clear guys? Now interpolate the number of persons living in the age of 25 years. So here there are totally 3 steps how this Newton's method is to be calculated. Step number 1, the leading difference table has to be calculated. That is the first step. Leading difference table. If you look at the board, then you will be understanding what do you mean by leading difference. So and then x has to be calculated, value of x to be interpolated minus value of x at origin divided by common difference between or adjacent values of x. Clear? Now look at the question. Age 20, 30, 40, 50 and number of persons 53, 49, 36, 23. Clearly the missing is not shown, and the missing of x need not be the missing of missing of y need not be the missing of x value. Clear guys? So the leading difference delta 1, 49 minus 53, 36 minus 49, 23 minus 36. This way the leading difference, the first leading difference has to be calculated. y2 minus y1 or y1 minus y0. Delta 1, delta not 1 is nothing but the formula y1 minus y0, and then y2 minus y1, y3 minus y2. So this way. Number of persons. First let us consider, let x be the age and y be the number of persons. So that's the first step. And then calculate the leading difference. Delta 1, 49 minus 53, you will be getting minus 4. 36 minus 49, you will be getting minus 13. 23 minus 36, you will be getting minus 13. And delta 2, the second leading difference. Once again from the first leading difference we should subtract. Minus 13 minus of minus 4, it will become plus 4. So minus 13 plus 4 is nothing but minus 9. And then minus 13 minus of minus 13. So minus of minus 13 becomes plus 13. So minus 13 plus 13 becomes 0. and delta 3, the third leading difference, 0 minus of minus 9. 0 minus of minus 9 is nothing but plus 9. See, this is how the leading difference. Unless and until it reaches to single observation, we should keep on do the leading differences. Clear? Delta 1, delta 2, delta 3, delta 4, delta 5 and so on. So it depends upon how least the value reaches. I mean least value in the sense the first one. From delta 1 to 3 observations, 4 observations we converted to delta 1 3, again 3 to 2, 2 to 1. It's a kind of triangular kind of thing if you observe. Okay, the leading difference must reach to single observation. There we have to stop calculating the leading differences table. And then the next step, finding the x. If you observe the formula, what is the formula of Newton's method? Yx equals to y naught plus x into delta naught 1 plus x minus 1 by 2 factorial into delta naught 2 plus x minus 1 x minus 2 by 3 factorial into delta naught 3. See, kind of a polynomial expansion. If you remember in mathematics, this is also same kind, polynomial expansion, right? So this is the formula, yx equals to y naught plus x into delta naught 1 plus x minus 1 by 2 factorial into delta naught 2 plus x minus 1 x minus 2 by 3 factorial into delta naught 3. Because here the leading difference is up to delta 3, therefore there the formula Newton's has been taken up to delta naught 3. Not in the sense the origin value, right? The first leading difference at origin and second leading difference at origin, third leading difference at origin, right? Now in that y naught is nothing but the number of persons origin value y. What is it? Y naught 53 and delta naught 1. So in the first leading difference, the origin first leading difference is delta naught 1 is minus 4 and delta naught 2 is second leading difference, the origin value minus 9 and delta naught 3, the third leading difference origin value plus 9. And then what about x? That is what x I have calculated bottom of the table. Just look at there. X equals to value of x which is to be interpolated. What is to be interpolated? Age 25 years. How many of them are living? Number of persons living in the age of 25 years. So that 25 will become the x because age we denoted as x. So 25 is the x which is to be interpolated minus value of x at origin. What is the value of x at origin? First value 20 divided by the common difference between adjacent values of x. So the common difference is 20 to 30, 30 to 40, 40 to 50, 10. So 10 is the common difference. So 25 which is to be interpolated minus 20 divided by 10, that equals to 0.5. As per the formula, we need x minus 1 and x minus 2. If you look at the formula, x minus 1, x minus 2, like that they are there. X we calculated 0.5 and then x minus 1, 0.5 minus 1, nothing but minus 0.5 and x minus 2, that is nothing but 0.5 minus 2 is minus 1.5. So why I have calculated here is directly you can substitute these values in the formula, right? Now look at the formula there, yx equals to y naught plus x into delta naught 1 plus x minus 1 by 2 factorial into delta naught 2 plus x minus 1 x minus 2 by 3 factorial into delta naught 3 and so on. But here this problem we had up to delta 3 the leading difference. That's why till delta naught 3 I have considered. So substitute all the values which I have put in the box from y naught. 53 plus x 0.5 into delta naught 1 is minus 4 plus x minus 1, that is 0.5 into x minus 1 is minus 0.5 divided by 2 factorial is 2 into 1 2 into delta naught 2, that is minus 9 plus 0.5 into minus 0.5 into minus 1.5 x minus 2 divided by 3 factorial, 3 into 2 into 1 6 into delta naught 3 is plus 9. After simplifying you get 53 minus 0.5 into 4 is nothing but 2, there minus 4 is there, therefore minus 2 plus 0.5 into 0.5, how much? 0.25 There minus is there, minus of minus 9 is nothing but plus, so divided by 2 is nothing but plus 1.125 after simplifying. And then 0.5 into 0.5 into 1.5, there minus into minus plus it will become, so 0.5625. After simplifying this step by step, you will be getting the value yx equals to, x is nothing but 25, y 25 years equals to 52.68, nothing but 53% approximately. So the number of persons living in the age of 25 years is 53. So 53 persons are living at the age of 25. Are you guys clear? So this is the stride problem from Newton's method. Now in this Newton's method, what are the conditions to be applied? Condition number 1, there must be a common difference among x independent variables. Yes, of course it has to be. And second point is, there, like binomial expansion method, the missing value of y must be a value of x, but in Newton's method it need not be. In this question only you can easily observe there is no missing shown in the table. And did they mention in the question this is from Newton's method? No. By seeing the table itself, question itself, you can identify that which method is applicable. Am I clear, guys? So this is the basic problem of Newton's method. Now, so there is one more method which the question will be asked in this manner. Age of below 25 years, above 25 years, under 25 years. So this way, below, above, less than, more than. So this kind of things will be given. Clear? So that problem we are going to look now. Okay, look at this problem now. This is another kind of problem from Newton's. Calculate the number of workers earning more than rupees 650 per week. More than rupees 650, I have underlined, see. It is asked more than rupees 650. Remember. Now, weekly wages up to 500, up to 600, up to 700 and up to 1000. What does it mean up to? Nothing but less than. Remember. Less than 500, less than 600, less than 700, less than 800, less than 900, less than 1000. And number of workers 50, 150, 300, 500, 700, 800. Guys, one thing you remember, the weekly wages are given in open-end class, that is less than 500, less than 600. So this one, right? So we cannot convert this as an interval because less than 500 means the first gap up to where you can take it. From 0 to 500 can be taken or not. And the next one is up to 600. Comparatively the previous one, that can be taken as 500 to 600. Next one 600 to 700. But the initial we need at origin, exactly, if you write like that, the condition will not be satisfied. That means the common difference will not be satisfied. First observation is up to 500. Up to 500 means from 0 to 500 also can be taken, and you cannot decide that from least to highest, least to up to 500, right? You cannot decide the interval, and the remaining all can be decided by comparing with the previous interval. Up to 500 it is given, next up to 600. So in between we can observe that 100 gap, but before 500 what is the gap, what is the magnitude, cannot be set. So the condition will not be satisfied. That is the reason we are unable to convert this data into class interval. Remember. Now up to 500, up to 600, nothing but less than 500, less than 600, less than 700, up to less than 1000 it is given. And look at the number of workers, frequencies, 50, 150, 300, 500, 700, 800. It is in a kind of LCFs, increasing order. And as you all know the condition, when the class intervals are given in terms of less than, obviously the frequencies must be in less than cumulative frequencies. Remember, that means in increasing order. Obviously both the things are given the same way, right? Less than it is given, and the frequencies are also given in cumulatives, right? Less than cumulative frequencies. Directly we can calculate it. See, first more than 650 per week it is asked, but the table is given about less than and less than cumulative frequencies. We cannot convert. If you want to convert, what we have to do? Again, converting these weekly wages to more than kind, and then number of workers LCFs to frequencies and frequencies to MCF. It's a time taking process and laborious process. That is the reason, as it is, you calculate first. Let it be. First, initially what we need to calculate? Up to 650 we calculate. According to the question, more than 650 we need, right? More than 650 if we want means till 650 what all the workers were there, if you remove them, obviously remaining all the more than 650 or no. So in such case, we will calculate this problem now. So less than cumulative frequencies are given. First let us calculate less than 650 only. I mean up to 650 only we will calculate. Now first leading difference, delta 1, 150 minus 50, 100, 300 minus 150, 150, 500 minus 300, 200, 700 minus 500, 200, 800 minus 700, 100. And again delta 2, 150 minus 100, 200 minus 150, 200 minus 200, 100 minus 200. You will be getting 50, 50, 0 minus 100. The same way the leading difference up to delta 5 you calculate it. Right? And all the origin observations, origin value should be put it in box. Now first x has to be calculated. As per the formula, up to delta 5 has to be written. So y0 plus x into delta naught 1 plus x minus 1 by 2 factorial into delta naught 2 plus x minus 1 x minus 2 by 3 factorial into delta naught 3 plus x minus 1 x minus 2 x minus 3 by 4 factorial into delta naught 4 plus x minus 1 x minus 2 x minus 3 x minus 4 by 5 factorial into delta naught 5. So up to delta 5 the leading difference table has to be taken. And then first find out y0. Y0 is nothing but the initial frequency, number of workers 50, and delta naught 1 is 100, delta naught 2 is 50, delta naught 3 is 0, delta naught 4 minus 50, delta naught 5 0. And x we have calculated, see under the table, x equals to the value of x which is to be interpolated. First of all, forget about the more than. Now let the problem we calculate about less than kind only. So 650 minus 500 divided by the common difference 100, that equals to 1.5. See, up to x minus 4 we need x minus 1, x minus 2, x minus 3, x minus 4. Calculate all those. X is 1.5. So x minus 1 0.5, x minus 2 minus 0.5, x minus 3 minus 1.5, x minus 4 minus 2.5. Then all these observations has to be substituted in the formula. After simplifying it, you will be getting the value 217.58, approximately 218 workers. Now this 218 workers is for up to 650 rupees per week, right? 218 workers are collecting, having weekly wages less than 650 up to 650. But the question is asked about more than. So as you all know that these cumulative frequencies, obviously this last value will become the total, right? Total number of persons. Now total number of workers how many? 800. Now we need to calculate more than 650. Up to 650 we calculated 218. From total of 800, if you remove 218, remaining people all are who are earning more than 650 or no? So under that condition we can take it 800 minus 218, that equals to 582. So this is way in this way the problem has to be calculated, right? In the next coming video, so in the next video I would like to give you few more problems based on this kind of method, right? More than, less than, how the values have to be taken. Clear guys? So with this I am going to wind up this video. Please observe, practice thoroughly. Okay? Thank you once again. Just have a look everybody, the same problem. Okay guys, please revise the things. Thank you.